In this lecture, I'm going to briefly cover the law of reflection, which might sound impressive, but is actually very simple. The law of reflection mathematically describes the angle at which light is reflected off a surface. If you have a simple flat mirror, let's say that's this surface I've drawn, and an incoming light wave, obviously light travels in a straight line, you'll see a reflection pattern like this. We can identify two angles in this picture. Here is the angle of incidence, we'll call it theta I, and here is the angle of reflection, we'll call it theta R. The law of reflection states that the angle of incidence, theta I, is equal to the angle of reflection, theta R. This simple rule can be used to describe the properties of much more complex surfaces, such as a paraboloid disk. Let's imagine this shape here as a paraboloid, and let's think about how light will behave as it enters this surface. Here's our angle of incidence, and the angle of reflection should be the same, so it should look like this. And we'll see the same from the other side, like so. And if you draw enough of these lines, you'll notice that they all converge at a particular point. This is called the focal point. Happens to be right here. It should be along the midline of your paraboloidal surface. This property of focusing incident radiation is very useful and can be explained using the law of reflection. This principle is what underlies the shape of satellite dishes, which are used to collect everything from signals for your television to radio waves that are supposed to come from alien civilizations.